I'm Dave Baring, Technical Director here at TriStar, and welcome to another Tech Talk. We've talked a lot in some of our other videos about the Rulon product line. It's a very important product here at TriStar. We have a long history with it. And as we've mentioned in some previous white papers, there are some reasons why the Rulon material has been around since the early 1950s. It is a product that's built with staying power. It's a product that has proven itself for decades, and the reason for that is that there's extra processing techniques that are considered during the processing of Rulon, and that's something I wanted to talk to you about again today. There's really three areas that we try and focus on when we're manufacturing a PTFE product. There's literally dozens and dozens and dozens, probably in the hundreds of people out there that can mold Teflon. It doesn't take much, to be honest. You need a press and an oven and a little bit of working knowledge about what makes it all tick. But there is more of a science to it when it comes to producing a material that is really effective for the long haul. And that is especially true when you're talking about materials that are used for seals and bearings. These are applications where you can have a variety of pressures and temperatures and different working conditions, and so you don't want to tempt fate by having a material that is of a lesser quality. So the three areas that we focus on in the production of Rulon are these. Number one, controlled molecular weight. Now, why is that important? Well, the molecular weight measures the polymer chain length, which is very important in determining the material's flex life, its tensile strength, and its elongation. Those are all important things when you're talking about a seal or bearing. These will affect the performance properties, and that in turn affects how long that bearing or that seal is going to last. Number two is controlled crystallinity. Now, where crystallinity comes into play is simply controlling that level, that percentage of crystallinity in the material, and being able to understand how that affects the specific gravity. As you increase crystallinity, you increase the stresses, especially compressive stress. You're also decreasing the flex life. The recovery values are going to change. Permeability will change. And that all leads to different wear properties and frictional properties as well. The number three item is controlled porosity. Now, all PTFE materials are porous. That's a given. And it's the control of that porosity through crystallinity controls that gives us probably the most important parameter as far as performance. Porosity can mean a lot of negative things. If you have a lot of porosity, you can generate more microscopic fractures in the material. You can also see permeation problems, especially if you're using these materials for like gas seals or environments where there could be chemical leaching. So porosity is something that needs to be very closely watched. The Rulon materials pay attention to these three manufacturing issues. And so it's very important for you to remember that not all materials are the same, especially when it comes to PTFE. Add to that the problems that we've incurred over the past few years with the shortages, the price increases. The reliability of the base resins has come under some fire over the past few years. There's a lot of offshore material that makes its way into the marketplace, some good, some bad. But you can rest assured that with the Rulon product, all of that is very, very tightly controlled. The sourcing of the material, the classification of the material before it even gets blended, and certainly the processes of molding and sintering, which is where these three items of molecular weight, crystallinity, and porosity come into play. All these things are critical to performance. So when you're looking for performance, then you need to look to Rulon. Thanks again for watching, and we'll see you on the next Tech Talk.